part 2 of 11.2. We're just going to do a couple of examples here of derivatives of parametric functions, and then there's a few more definitions and theorems that we need to look at. So a couple of examples first. Again, this could be like a homework question. It might say something like find, oops, bad start. We're going to fix that. So find the second derivative of dy dx. Okay. And so find that, and let's say we're given the parameterization x is t minus t squared, y is t minus t cubed, and then we'll just assume that the interval is the whole number line, so from negative infinity to infinity. Okay, so to find the second derivative, first we have to find the first derivative. Remember that first derivative, dy dx, just comes from the formula. We wrote it in the first video. Dy dx is going to be the derivative dy dt divided by the derivative dx dt. Right? For us, the derivative of y with respect to t is going to be 1 minus 3t squared. Derivative of x with respect to t, 1 minus 2t. And then you can just leave it like that. There's not really anything that you can do to simplify stuff here because of these minus signs. You can't factor anything, and because there's no factors, nothing cancels out top and bottom. Okay, so from there, we need to differentiate again. All right, here's where you have to be careful. All right, so differentiating again means that we're doing this. We're going to take dy prime and then differentiate that with respect to x. All right, and remember we had a formula for that, which we also wrote up top. That's taking dy prime dt and then dividing that by a dx dt. So that's just the formula. So we're going to separate this formula out a little bit. Let's first find just that top numerator part there, the dy prime dt. That's going to be taking the y prime that we got up here. Remember, dy dx is y prime, not dy dt. So dy dx was this thing. Now we need to take the derivative of this thing with respect to t, which is going to be a quotient rule. So we're going to get a big fraction here. We're going to take the bottom times the derivative of the top minus the top times the derivative of the bottom. And that's all divided by the bottom squared. All right, so it's probably been a while since some of you have done some quotient rule stuff. Bottom, derivative of the top, minus the top, derivative of the bottom over the bottom squared. We're going to clean that up a little bit. So here I'll distribute the negative 6t into this parentheses, distribute the negative 2 into this parentheses. Still a big fraction. Oh, sorry about that. Okay. So my numerator now is going to be that negative 6t plus 12t. Oh, we got to be a little bit careful because there's another minus sign here, right? So really this is a positive 2 that we're multiplying into here. So we're going to get plus 2 and then minus 6t squared. And that's still all divided by the denominator. I'm not going to multiply this denominator out because I'm eventually going to want to factor stuff anyway. The numerator up there, just combining like terms and kind of rearranging it a little bit. We have a 6t squared floating around. I forgot this is supposed to still be a big fraction. A 6t squared floating around. We have a negative 6t when we combine those like terms, and then a positive 2. In my denominator, I have the 1 minus 2t squared. All right, at this point, you would want to try to factor the numerator to see that if it would cancel out with the factor here in the denominator. I'll just tell you that it's not, so don't worry about that. Okay, this whole thing, remember, is only the numerator of the formula. So we can plug it in now. Dy prime dx is going to equal to a big fraction. This awful looking thing is going to be its own fraction here in just the numerator, the 6t squared minus 6t plus 2 divided by the 1 minus 2t squared. All right, so that's that dy prime dt, and now we're going to divide that by dx dt. Dx dt, remember, is just taking the derivative of x with respect to t, which we've already done once. That's that 1 minus 2t. Okay, and now you want to simplify this down a little bit. So we have some complex fractions going on. However you want to think about simplifying this, do it. whether it's multiplying by common denominators or just thinking about it as actual division and then multiplying by the reciprocal, but you're going to end up with this. So you're still going to have that 6t squared minus 6t plus 2 up top, and then we're going to be dividing that by 1 minus 2t, but now it is cubed. Okay, this is our final answer, right? So this is the second derivative of y with respect to x. You can think of this as acceleration, or you can think of that as giving the concavity of your function. Okay, let's do another example here before we end this video. All right, another thing that we can do with parameterization is something like this. Find the area enclosed by the asteroid. And so the asteroid in math is this, and I'll show you a picture of it here in just a second. It's cosine cubed t as the parameterization of x. Y is going to be sine cubed t. And this is going to range from 0 to t to 2 pi. Okay, so I can't draw a good picture of this, so I'm going to flip over to the book here, and hopefully the book will have a nice little picture of it. There it is. So this is the asteroid. Cosine cubed t, sine cubed t from 0 to 2 pi, and it maps out this kind of starry looking shape. Okay, but we're trying to find the area of that crazy looking shape. So just going over back to the picture here, I hope everyone agrees that the area of the entire thing we could get by just finding the area of the first quadrant and then multiplying that by 4. So we will find the area of the first quadrant, Q1, and multiply by 4, since it's all symmetric. Okay, so we'll just do that, right? So the area, I know it's been a while since we looked at that, but we did do area stuff way back in the day, back in chapter 6, I think it was, or maybe even saw it in Calc 1. So we're going to take 4 multiplied by an integral. Now this integral, let's write it out in just rectangular coordinates. In rectangular coordinates, my first quadrant, going back over to the picture now, my first quadrant is going from 0 to 1. And if I want to find the area, I would integrate over the function y with respect to x. Okay, so one way of writing it out would be like this, dy dx. So this is just the generic formula for an area. The integral of the function y with respect to x. I know that's a weird way to write it out, but that's the same stuff you were doing in Calc 1 and then earlier here in Calc 2. But we don't have a function of y with respect to x. We have x and y separately as parametric functions, but we can still plug it in. We already know the y, right? We were given y is sine cubed t. The only other thing that we would have to find is that differential dx. And we can find that by just differentiating x and then putting a dt on the end of it. So the derivative of x, the parameterization up here, is going to be 3 cosine squared t, and then multiplying by the derivative of cosine, which is a negative sign. So just to simplify it down a little bit, negative 3 cosine squared sine. Oh, and then I forgot my dt. I just talked about it and I forgot to write it. All right, so the differential dx, 3 cosine squared times the derivative of the inside, negative sine t dt, and then just simplifying it out a little bit, negative 3 cosine squared t sine t. All right, and then we just plug that back into our integral. So that means that my integral, the area, is still going to be 4 times, so here we have to be a little bit careful, because we have now changed the variable that we are integrating over. We are no longer integrating over x, we are integrating over t. So we need to have the endpoints of t in the first quadrant. The endpoints of t in the first quadrant are going to go from 0 to the angle pi over 2. Just going back over to the picture real quick, right? If you want to think about this as the unit circle, I'm integrating from 0 to pi over 2. Just the first quadrant. Okay. And then plugging in all the other stuff, we have y, which is sine cubed t, times dx, where dx is that negative 3 cosine squared t sine t, dt. All right, and then just to multiply the signs together, oops, sorry about that. This is still going to be the integral. Still have the 4 out in front. From 0 to pi over 2. And then, you know what? Let's multiply out that negative 3 as well. So instead of having a 4 out in front, we'll have a negative 12 out in front. All right, that'll make things a little bit nicer. So now we're going to have sine to the 4th of t, and then cosine squared of t dt. And then you just do that integral, and that integral sucks, but it is something that we saw back in chapter 8.3. So remember, we looked at integrals where we have even or odd exponents on the cosines and sines. So I think I'll just to go over to the book here real quick to show you the final answer, and then maybe I'll talk through it at the end of the video. So this is how you do it. They left it like this, which is perfectly fine, but then they multiplied it all together. And then remember that when you have these even exponents on sines and cosines, you want to use these trig substitutions. Sine turns into 1 minus cosine 2t over 2. Cosine squared turns into 1 plus cosine 2t over 2. So you do these substitutions for both of them. Multiply it all out. Here they brought out that 1/2, or 1/4, sorry. Then they multiplied the numerators together, continued combining like terms and multiplying stuff out to be here. Let's see if they have more stuff on the next page. Awesome. So then they split it all up. So these first two terms, the 1 and the negative cosine 2t, that you can just find the antiderivatives from right away. Here we have another even exponent, which means that we're going to have to change that again. They changed it in kind of a weird thing here. I wouldn't have done that, but they did that, which is perfectly fine. I would have probably changed this into another one of those 1 plus cosine. It'd be 4t over 2. I'll write this all out here in just a second. The cosine cubed, that you'd have to use the other trick that we saw in that section, which is to take one cosine out and then change the other into 1 minus sine squared. Okay, so the final answer is 3 pi over 8. I'm going to actually work that all out. If you want to work this out on your own, then by all means just stop the video here. But here's my attempt at working it all out to see what we get. Oh, they had a positive 12 out in front too, didn't they? I should have double checked that. Oops. They did have a positive 12. All right, why are you positive? Did I do a derivative wrong? Derivative of cosine is definitely negative sine, right? I asked to the class. All right, we'll just pretend that you guys see the mistake and I don't. It doesn't matter. Positive 12 out in front here. So here we go. We're going to do this integral. So the 12 stays. We're still going to have the integral from 0 to pi over 2. And then just like the book did, we're going to think of this as sine to the 4th t, as sine squared all squared. So we're going to substitute that with the identity 1 minus cosine of 2t divided by 2. And that's still going to be squared. Okay? The cosine squared, we're going to substitute out with the identity 1 plus cosine of 2t, all divided by 2. That one's not going to be squared, and we still have dt. Okay? Still have the 12 out in front. Oh, sorry. Still from 0 to pi over 2. All right, now what I would do is that I have a 1/2 here and a 1/2 here, which would multiply out to be a 1/4 out in front. I would also go ahead and FOIL out this 1 minus cosine 2t. So just write two of those side by side and FOIL it. We would get 1 minus 2 cosine 2t plus cosine squared of 2t. Okay. This other one I'll just leave as is. Just the numerator, because remember we already pulled the 1/2 out, so 1 plus cosine 2t. All right, I'm going to pull that 1/4 out to the front here, and then I'm going to multiply these things together. So now out in front, we're just going to have a 3/2, or just a 3. Didn't they have 3/2 in the thing we were looking at, though? Going back to the book. They do have a 3/2. Oh, because it's squared, of course. Sorry. This 1/2 is squared here, so that's really a 1/4. times another 1/2. This should be a 1/8 out in front. That's why 12 divided by 8 gives you the 3/2. All right. Still have the integral. Still going from 0 to pi over 2. Multiplying these out, I'm just going to multiply every term of this first parentheses by the second parentheses. So I'm going to multiply 1 by each of these two terms, which is going to give us 1 times 1 plus 1 times cosine 2t. Okay. Then this negative 2 cosine 2t times each of these terms. So you're going to have just times 1 is another negative 2 cosine 2t. And then multiplying the negative 2 cosine 2t with the plus cosine 2t is going to give us a negative 2 cosine squared of 2t. All right, and then cosine squared 2t times these two things. So we're going to get a cosine squared of 2t. And then we're also going to have a plus cosine cubed of 2t. Great, and then we still have the dt on the end. Oops. Okay. Still have the 3/2 out in front. Still have the integral from 0 to pi over 2. Combining like terms together, we just have a single 1 that's floating around. We have 2 of these, which we can combine together just be a negative 1 cosine 2t. We have 2 of these, which we can combine together to be a negative cosine squared of 2t. And then we just have that lonely cosine cubed of 2t at the very end. Awesome. All right, so yeah, this is where we want to separate stuff out. We're going to think of this as 4 separate integrals. The antiderivative of 1 we can do very easy, that's just t. Antiderivative of cosine 2t we could also do fairly easily. It's just these other 2 that can be a little bit difficult. So this is where I would go to scratch paper, and I would find some of these separately. So let's just do the integral there of cosine squared of 2t dt. All right, to do this one, we're going to use the same substitution that we did before. I'm going to rewrite cosine 2t using that identity. It's 1 plus, but now it's going to be cosine of 4t all divided by 2. Okay, you can pull the 1/2 out if you really want to, and then it's going to be the integral of just 1 plus cosine 4t dt. And then that we can do fairly easily. We can just do each of them separately. So we still have the 1/2 out in front. The antiderivative of 1 is t. The antiderivative of cosine 4t is going to be plus 1/4 sine 4t. Right? You take the reciprocal of the number on the inside, and then you anti-differentiate the cosine. All right, so that one's done. That's the cosine squared. We also need to do the cosine cubed. So cosine cubed of 2t dt. Remember with this one, this is where you want to separate one of the cosines out. Oh, sorry, he keeps going up. So we're going to write this as cosine 2t times cosine squared of 2t. I have way too many parentheses there. Sorry about that. Oh, I can't write dt either. Perfect. Okay. We're going to leave that cosine 2t just out in front, but that cosine squared, this is where we want to rewrite that as sine squared. 1 minus sine squared, sorry. I said it, but I didn't do it. I also forgot my integral symbol again. All right, so the integral of cosine 2t times 1 minus sine squared. All right, this is where we want to do a u substitution. You're going to let u just be sine of 2t. Then du would be 1/2, and it would be negative cosine 2t dt. Just to simplify that down, negative 1/2 cosine 2t dt. Okay, so you would have to multiply the negative 2 over to the du side, and then you can substitute it in. So substituting in my u and my du, this cosine 2t dt would substitute out to be just negative 2 du. And then we'd still have this 1 minus sine squared thing. I'm going to have to put it in here. So 1 minus sine squared, that would be 1 minus u squared. guess I don't need those parentheses on the outside. I'll leave them there, though. I don't feel like fixing that. So then the antiderivative of that, distributing the negative 2 in, we're going to have negative 2. The antiderivative is negative 2u. I can draw my integral symbol now, too. Sorry. So negative 2u. And then this is going to be positive 2u squared, which has antiderivative of plus 2/3 u cubed. And then don't forget that u, we actually had equal to something. U was the sine 2t. So this is the same thing as negative 2 sine 2t plus 2/3 sine cubed of 2t. Okay, great. But now that we've done all that work, now we can go back to here. I'm just going to copy paste this down. So this is where we were at before. 3/2. Integral 0 to pi over 2, 1 minus cosine 2t minus cosine squared 2t plus cosine cubed 2t. Okay, so we still have the 3/2. The antiderivative of 1 is just t. And then that's going to be minus the antiderivative of cosine 2t is 1/2 sine 2t. Then we're going to have minus the antiderivative of cosine squared we had found up here. This was the antiderivative of cosine squared. So minus 1/2 times t plus 1/4 sine of 4t. Okay? And then that plus cosine cubed, which had this antiderivative. Negative 2 sine 2t plus 2/3 sine cubed of 2t. Great. Oop. Oops. Anyway, you guys get the drill. It's hard to format some of these things sometimes unless you're perfect. So just substituting that in. 3/2 is all the way on the outside of all this stuff. 1 turned into t. Cosine 2t turned into this. Negative 1/2 sine 2t. Negative cosine squared turned into this. Positive cosine cubed turned into this. But don't forget that we're still trying to evaluate this between 0 and pi over 2. So I'm going to plug pi over 2 into all of that stuff. We still have the 3/2. Then t just changes into pi over 2. Minus, if I plug pi over 2 into here, 2 times pi over 2 is pi, and sine of pi is 0. All right, and that's going to be minus 1/2 times t, pi over 2, plus, again, plugging pi over 2 into here, pi over 2 times 4 is 2 pi, and sine of 2 pi is 0, plus 0 plus 0. All right, so that's just plugging pi over 2 in, and we're going to subtract that by plugging 0 in. So I hope you can see that plugging 0 in is just going to give me zeros everywhere. 0 for this t, sine of 0 is 0, another 0, sine of 0 is 0, 0, 0, 0, 0, all the way down. Okay, so finally, just to simplify it out, here I have a pi over 2 and negative pi over 4, which is going to be pi over 4. So we end up with 3/2 times pi over 4, which is 3 pi over 8. Which I think that was the answer that they got in the book. I hope so, because that took a lot of time and a lot of effort. And if it's the wrong answer, I'm going to be quite upset. Oh, thank goodness, 3 pi over 8. Yay, we did it. Okay, great. And then I know we kind of lost the forest through the trees here, but don't remember, the whole point of that was to find the area enclosed by that asteroid. So the area enclosed by this asteroid, this thing has an area of 3 pi over 8 square units.